Yeah, so I would say we start now. Hello and welcome again to the next online expert seminar, Operation with Testo today. So we will show you how ventilation systems into operation. So we will concentrate on the commissioning and adjustment process of balanced ventilation systems. My name is Adrian Gut and I am working as a technical project at the Zehnder Group. And I'm also very happy to have an expert from Testo in the session. For everybody who doesn't know the company so far, Testo is a measurement device manufacturer, also located in the Black Forest in southern Germany. And Mr. Tobias Thieme from Testo will show you how to measure volume flows at air outlets with their devices. So, hi, Tobias.
Hello, Adrian. Thanks for the introduction. Yes, welcome also from my side. I worked for 2.5 years at Testo in the Black Forest here in Titisee, and as a product manager, I'm responsible for the climate portfolio and measuring parameters like temperature, humidity, air velocity, and so on. So yeah, looking forward to this webinar, and thanks for joining us.
Yeah. Thank you, Tobias, for being part of this webinar today. I'm sure this topic will be interesting. And then I would say So at the beginning, I would like to point out why we are actually talking about this topic. So why is commissioning and adjustment of balanced ventilation systems important? So basically, we do commissioning to ensure that the installed system is working as intended, that it fulfills its purposes. You can imagine even the best installation doesn't work when commissioning has not been carried out properly. So what are these purposes? What do we want to achieve with our system? You know, new builds are very airtight and we have humidity inside. And since there is no more infiltration, we need to take out the humidity of the building, which is inside. So we want to protect the building structure from humidity damages and ensure a healthy indoor climate without any molds and bacteria caused by humidity. Secondly, we want to provide comfort through a permanent fresh air supply. So the CO2 levels should not exceed permitted limits. Dust, pollen, noise should be kept out of the building. So we want to create a healthy and comfortable indoor climate. And last but not least, we are also talking about energy efficiency. With the heat recovery, we can save energy on the heating and cooling load of a house. And also the system itself should operate in an efficient way. So this can only be ensured with a proper commissioning and adjustment of the outlets. So if commissioning is not done properly, we can not ensure these benefits at its best. So for example, if the volume flows are too low, the humidity cannot be transferred, ending up in mold formation and damages at the building structure. And too high volume flows lead to draughts, noise, and inefficiency. Let's take a look on the standards that relate to this topic. So which standards can we use? There are 3 main standards that relate to commissioning, adjustment, and measurements at ventilation systems. Of course, this depends on your local regulation, but these 3 standards are used in Germany or in Europe. Of our customers worldwide refer to them as well. So firstly, we have the European norm 16798, energy performance of buildings, and especially part 17, which relates to ventilation of buildings. And this norm defines methods and requirements for inspection of ventilation systems. The main focus is the energy consumption and the system efficiency. And this norm is for residential and non-residential purposes. Secondly, we have the European norm 14134. This norm is meant for residential purposes only. So it comes a little bit closer to our application. And this norm defines how to carry out functional testing. So how to measure basically, how to measure volume flows, how to measure the pressure, air velocity, sound levels, and of course also the power consumption of the ventilation unit. And this norm also focuses on comfort aspects and how to ensure them by doing functional testing. And then we have the German standard, DIN 1946, Part 6. And this is the one we are using to plan and design our ventilation systems. It is made for residential purposes and includes all requirements. So from the planning, how to create a ventilation concept, to the design, how to calculate the volume flows, and also how to carry out commissioning, measurements, and maintenance at ventilation systems. This is a central standard for residential ventilation. Based on that DIN, we have a calculation tool and a design tool at Zehnder, which is called Comfoplan. With that tool, you can go through the whole design process, so starting from the idea to the material list at the end. You can also register for that tool online. When you begin such a project, you need to determine at the beginning whether a ventilation system is necessary at all. By typing in some building parameters, the tool calculates the results. So you need to type in which building type you have. So is it a single family house, multi-family house, or row house, and so on. What is the external wind influence? What is the insulation level and the air tightness, of course, the energy standard, and also how many people are living in that building, because it is recommended to calculate at least 30 cubic meters per hour per person. And the next step is to determine the rooms and their purposes, and also their dimensions, of course. Based on that, the tool calculates the required volume flows. And at the end, you get a ventilation concept, which is based on 4 stages, which you can also find at our ventilation units. So the first preset is humidity protection. And this is the mode, the ventilation mode, when occupants are on vacation, for example. And this mode ensures a minimum air exchange. Then we have reduced ventilation, which is also called absent mode. This is when the occupants are not at home, when they are at work, for example. And then we have nominal ventilation, preset 3. So when there is a normal use of the house, when people are at home. And this volume flow is also used for commissioning later on. And then we have preset 4, which is intensive ventilation. And this preset you are using when you have a party at home, for example. Yeah. But how are these volume flows are calculated exactly? There are 2 different approaches. The one with the higher result is taken into account. So firstly, we can go with the required fresh air supply. As I already said, we calculate with 30 cubic meters per person per hour. Yeah. The result is typically lower than the calculation based on the usable area. So this is the formula from the DIN, from the standard. So you have some factors and you need to set in the area and get out the volume flow in cubic meters per hour at the end. I don't want to dive too much into theory at that point. So This is the formula running behind it. On the other side, there's a calculation method based on the extract air flows. So the standard defines rooms, and these certain rooms get a certain amount of volume flows. So for example, every bathroom is weighted with 40 cubic meters per hour. Same applies for a kitchen, fitness room, or sauna. And on the extract air side, we also have other rooms like utility, dressing, cellar rooms, or toilet. And these rooms are weighted with 20 cubic meters per hour. You can see the area is not considered extract air. It is assumed that the loads are equal in every bathroom, for example. So it's not a matter of the size of the room. You also can adapt this to a certain level, so you have factors to weight the rooms differently. At the end, the higher volume flow is chosen and the smaller one is adapted to the other one, so that the system is in a balance at the end. This is how the comfort plan calculation looks like at the end. You can see different rooms divided in extract and supply air rooms with the according areas and the volume flows at the end. So this document, together with a layout, as you can see it on the right-hand side, is given to the service technician who will carry out commissioning and the adjustment of the ventilation system. So until now, I've shown you how we come to these results, what is the theoretical background behind it, and we conclude in this documentation with the calculation of each single room, so that we now can proceed with the technical or practical part. So with that documentation, you then go on site, and before we start with the actual process of commissioning, we need to check the whole system, whether everything is installed correctly. And therefore, we have a checklist which should be taken to every commissioning. So at the beginning, you need to check, for example, if the silencers are in a correct position, and is the condensation drain connected, if it is necessary at all. You know, for the enthalpy exchanger, you don't need a condensation drain, for example. Then you can you need to check the wiring of the unit. Are the outdoor grills clean? And very important, you need to check if the filters are in the unit and if they are in the correct direction. And after checking this, the actual process of commissioning can be started. So when you start a unit for the first time, or when you reset it completely, you are asked to start a commissioning wizard automatically, which leads you through that process. So I take up the most important points of that process, of that wizard. So at the beginning, you will be asked what is the orientation of the unit. We have two options, left and right version. Right version means that the supply and the extract air connections are on the right. So the connections which are going into the house, the ones which are going out of the house are on the left side. And a left version means the other way around, the supply and the extract air connections are on the left. So it is always the direction into the house. So now you can see the picture on the right-hand side, and I would like to check if you understood this. So I would like you to ask which orientation has the unit in the picture on the right upper corner. Please take a choice. I just give you a few more seconds so that you can watch the picture and Then I'll start the poll. %50 of the participants already voted. So I'll wait a few more seconds so that everybody can take a choice. Feel free. So yeah, nearly everybody took a choice and we have a result which is almost 50-50. So yeah, I will close the poll. So 57% said right and 43 said left. So actually the majority was wrong because this is a left unit, because you have the silencers on the left hand side, and the silencers are typically installed at the inside connection, or they are always installed at the inside connection. So the pipes on the left hand side are going into the building. The pipes on the right or going to the right are leading to the outside. So this is a left unit. If you change the orientation of the unit at the beginning, you don't need to adapt anything, except you need to check the filter position, because it might be you have different filter classes for outdoor and indoor air. So you only need to check the filters. The next step is the maximum flow test to get out the maximum flow. This varies with the system pressure drop. So if you have long ducts and many bands, the maximum volume flow will be lower compared to a system with less pressure drop. So when you are doing the maximum flow test, you need to make sure that all valves are completely open and all windows and doors are closed during the testing. And afterwards, you will be asked to type in the set volume flows for the 4 stages. So the away airflow, preset 1, low airflow, preset 2, medium airflow, preset 3, and maximum airflow, preset 4. Here, you need to take out the values from the comfort plan calculation. And then you need to fine-tune all extract and supply air valves in the apartment. And therefore, you need to use a measurement device like a flow meter, for example, which will be shown by Tobias from Testo later on. And this fine-tuning takes a bit of time, depending on the size of the ventilation system and how experienced you are in adjusting the valves and grills. You won't get the perfect results after the first round of adapting, so you need to repeat that step to get an appropriate result. Our Zehnder service technicians typically need 2 rounds of adapting the valves, so it takes them 1 to 2 hours. We will take a closer look at this process on the next slides. So when you have done the fine-tuning, you can close the commissioning process. And at the end, when the system is adjusted and all the volume flows are okay, you can also help the end user to set advanced user menus, because they typically don't know much about ventilation systems. And in these advanced user menus, you can set, for example, the sensor ventilation. So if you have any sensors installed, like a CO2 or humidity sensor, you can type in these settings. Or you can also set a temperature passive program. So now I would like to show you how you can fine-tune the Zehnder valves or grills. At this point, I would like to show you firstly a short video about our comfort valve Luna. So yeah, the information won a little bit fast indeed, but I can explain it to you. So what we have at a Luna is an accurate adjustment system with 75 positions to reach the set point, volume flows exactly. I have one here, so you can just take the cover and then you can adjust the gap here. So this is the gap where the air flows out or in for the comfort valve Luna E. And here you can adapt it. And at the end, you just put on the cover again. Yeah, that's the comfort valve Luna, but we also have a wide range of designer grills in our portfolio. But so that we can cover every customer's flavor. Here we have the Comfort Grid Linea diffuser slot, which is available in different optics, but also different grills like the Roma or Torino, which are available in white or stainless steel. And these grills are adjusted by using the so-called composites. A composite comes along with 4 different caps to restrict the open area. The whole set is put into the tubes behind the outlet. So they are available for the Comfort Tube 75, Comfort Tube 90, and Comfort Tube Flat 51. Yeah. So now let's take a look at that process of fine-tuning, how to go on with the fine-tuning process. Here you can see a typical layout for a family house. We have a central unit, the Comfort Air Q350, outdoor air connection with Comfort Pipe Compact 160, and indoor connections with Comfort Tube 90. And for the outlets, we used Luna valves. The total volume flow, so nominal ventilation, is 202 cubic meters per hour, according to the calculation based on DIN 1946. And in red, you can see the supply air set points, so the calculated values, and blue the extract air set points. For convenience, we only take a look at the extract air flows, so the blue ones. And at the beginning, when all valves are fully open, the volume flows will be quite with slight differences due to different pressure drops in the air distribution system. The inlets which are closer to the unit have a bit more, like 43, 42 cubic meters per hour. The ones further away have a bit lower volume flows, of course, like 38 cubic meters per hour. And these values are marked in orange or in yellow in that case. So now we recommend starting with the valves that are close to the unit and have the lowest set points. So we adapt firstly these two valves. So we need 34 cubic meters per hour, but we have 43 at the moment. A little hint from my side, if you set the flows now a little bit lower, for example, to 32 instead of 34 as intended, you might hit the target value after you have adapted the other valves. And then you go on valve by valve. And yeah, every change in the system leads to a change at the other outlets. That's why you need to do at least 2 wounds. So in total, you have 4 wounds since you have supply and extract air. So in this case, if we move on, we need to adjust the valve, which has 49 cubic meters, and we want 45 cubic meters. Yeah, so this is a little bit tricky, but yeah, if you change something, the whole system will change. So you need, or you will get a feeling for this. But at the end, the volume flows don't need to fit 100%. So here we are already quite close. You could just adapt the one with 49 cubic meters, and then you can check what the other valves are doing. The goal should be at the end that the last valve, the one with the highest system pressure drop, is completely open, so that the fan needs to bring the least achievable pressure rise for that system, and therefore works in the most efficient way. So this is the way we recommend to adjust the system. I hope that was clear for you. So that's it from my side for the moment. Now Tobias will show you how you can do these measurements.
Yeah, thank you, Adrian. Just a short introduction for Testo. For the people who don't know the company, we are manufacturer of measuring instruments and located in the Black Forest, founded in 1957, so 60 years or more than 60 years of experience. And as you can see, we manufacture measuring instruments for nearly every parameter and all the target groups and different applications. So yeah, you can go on, thanks. Yes, and this I want to show you, Adrian have mentioned it before, so we have different outlets, especially in residential buildings. And for these outlets, we highly recommend to use funnels. So yeah, you can see in the pictures that the most measurements are done with funnels and measuring instruments with a flow meter. It's very easy and convenient because you can calculate automatically the volume flow and not only the air velocity. But from time to time, you've got outlets like, for example, the design outlets from Zehnder, where you don't have, in all cases, a fitting funnel. And therefore, we recommend the outlets, not the outlets, the measurement without a funnel. And if you do a funnel measurement, you have to differentiate between supply air and exhaust air. So in the upper line, you see 3 pictures for swirl outlets. And I think it's nearly the same if you have, for example, lunar wharf, because there are always turbulences at the outlets, at the wharfs. And therefore, you need a little bit of a distance that where the air, the outlet air, can calm down. So in our case, you see here in the right picture, we have something like a flow straightener. And if you have a look at it, this is something like you know from the bees. And this is so mentioned that the air is running through the small holes and is coming straighten to the 100 millimeter vein, and then you can measure more accurate and easier. And on the 3 pictures below, you can see what we have, or there are several outlets with supply air where the air is just running out, and so it's pretty easy to measure in front of the outlet. And then you have the other outlets like the lunar valve, where the air is running out of the sides, and there a funnel is more needed, definitely. And for the exhaust air, it's the same. If you measure without a funnel, you see the air is getting soaked into the outlet from all sides, and if you only measure in front of it, you will not catch up all the air which is running into the system. So thanks. Go on. So as I mentioned before, if you have a fitting funnel, we always recommend it because it's easier to calculate the airflow. So if you get bigger outlets, even or mostly used in non-residential buildings, so bigger outlets for more people in the building, then we suggest the loop method. There you go with the there you go like this in the at the outlet, and then you have to calculate the volume flow afterwards, or from time to time if the device is offering, then you can calculate it also automatic with the dimensions in the instrument. In the middle one, you see if you have a right funnel size, then it's also possible to measure it with the funnel. And on the right side, as I mentioned before, we have different opportunities. So this is, for example, 100 millimeter diameter, and then we've got the small one. It's called a hot wire probe. Is very sensitive and thin, and normally is getting used for duct measurements, but you can also use it for the design outlet in this case, for example. Okay, so at the end, you've got with the measurement equipment different advantages. So as I mentioned before, we've got the automatic volume flow calculation. If you are using a funnel, then you can click on funnel factor on, for example, or you can choose in our measuring instrument that you do a funnel measurement, and then the volume flow is getting calculated automatically. So you don't have to calculate the dimensions of the outlet and so on. So pretty easy. And with our new measuring instruments, you have also the possibility to enter customer data, including the measuring sites and documentation and reporting. So we have older devices like this one. It's called Testo 417. Pretty easy to use, and you the display, but you don't have a storage. So you can write the measurement value down on your paper, and so you have your report. But you have also newer instruments, like, for example, like this one, and there you can enter the dimensions directly from the outlet, and can go on and and create your reports inside the devices. And additionally, we've got a high large probe portfolio. So for example, you have here something with a 100mm vein probe, but you can also remove it and, for example, can put there the other probe. So you have very compact measuring instrument with a probe portfolio. So we offer also humidity, CO2, the air velocity, temperature, and a lot of other different specific probes for your needs. And yeah, so if you do in the one building the outlet measurements from time to time, as we mentioned before, you can do also pressure measurement, noise, or power consumption, and can save all the measurement results in one device, and yeah, and analyze everything. So I think we can switch to the camera, and I can show you a little bit some devices, some instruments, and how you normally use it. So am I okay? So I think it works. So as I mentioned before, this one is a pretty old device, but works very, very fine, and is highly recommended and used all over the world. So 100mm vein probe, for example, it's off, and then you just click it on, and 2 seconds later you already can start. And for example, we have here a pretty big funnel, yeah? And then you can click on the 100mm vein there. And for example, you have an outlet, and then you can put it on the ceiling. You have to take care that here that the material is fitting pretty good on the wall, that no air is running out. And this one here is exhaust air. And right now we've got, for example, a volume flow of 54 cubic meters per hour. And this, as I mentioned before, is exhaust air. And then we've got at the bottom, we have also extract air, supply air, sorry. And therefore, we adjusting the flow straightener, as you can see. And then we add on this additionally the funnel. It's working everything. It looks like a bazooka, but it's pretty smart. And then we can add it here on the funnel, on the outlet, and then measure the volume flow. And the air is coming here. It's a little bit turbulence, and then it goes through the straightener and calms down, and the measurement is done pretty easy and fast. And the other option, as I showed you before, is our new generation. And the new generation is working with Bluetooth. So as I mentioned before, the Testo 417 has no storage. So you have to write down all the results. And with this device, you click on the button and a green light or yellow light is connecting to a measuring instrument. For example, to our Testo 400 at the wall. And then you can also click on the right measurement menu, like funnel or outlet measurement. Then you can enter the customer data with dimensions and so on. And then you go with the 100 millimeter vane probe to the outlet and measure also the volume flow or the air velocity, and the instrument is calculating the volume flow. And then you can only you can just save it, report it, and send it by email or by Bluetooth to your office or directly to the customers, and combine it with your invoice, for example. So pretty easy and very flexible usage. And if you are interested after the air velocity or the commissioning and adjusting, then you can also use other probes like CO2 and measure other parameters as well with the same instrument, just what you need and what you want to measure. So yeah, for sure, I can show you as well that the flexible Bluetooth handles or can also be connected here to the funnels without any problem. So it's fitting as well, and you can start and stop the measurement just with a click on this button. So you don't need two hands, so you can put it up on the ceiling and click on the button to measure the volume flow. So I think, yeah, then we've got also a telescope, for example, and also an extendable, so we can go to ceilings for up to 2 meters, and also a 90-degree angle that you can measure at ceilings or wherever you want. So yeah, I think pretty fast, but we're in time, and I would like to hear some questions for you from you and answer it. Thank you, Adrian. Adrian, I think you're muted.
Yeah. So thank you very much, Tobias, for joining us today. It was very interesting, very appreciated. Before we start in the Q&A session, I would like to inform you about an upcoming seminar in July. This time, my colleague, Ms. Helena Hülsay, will show you different installation options for radiant heating and cooling ceiling systems. So you can scan the QR code for registration, and we will also note it in the follow-up email that you will receive tomorrow. So yeah, thank you for joining us today. Now we are here to answer you any questions that you might still have. So please feel free to use the chat box to raise any questions. So Tobias, there is a question for you. Do we have any difference in measurements using the funnel and the averaging method?
The funnel is in our measuring department. We have created a funnel factor, which is calculating the airflow, and it's a little bit complicated, but the airflow is not getting calculated for every air velocity the same. So if the factor for or the funnel factor is a little bit higher at higher air velocity and a little bit lower at low velocities, and due to the same area which the funnel sticks to, you don't have to or you only have to calculate it once, and you only need to click on the funnel factor or on the right measuring instrument. If you do the average method and you are calculating the airflow by yourself, or if you are going with the loop method, yeah, then you have to take care that you have a good average value. So, for example, is if the outlet is installed with some edges and so on, then you have in some areas of the outlet nearly no air, and on the other side of the outlet even more air, and therefore you have to be very careful. And therefore I would recommend, if you have a funnel and the funnel is fitting on the wall, on the installation, on the outlet, then I would always use this for higher accuracy from my point of view. And additionally, for the average method, if you get the krill, then you normally have to reduce the area with the krill material. So if you have a krill with only tiny holes, then you should reduce the complete area a little bit, because the dimensions are not correct if you say it's 30 and 40 centimeters, for example. This is fine for the answer?
Yes, the person said thank you. So
okay.
Yeah. So there's another question for you, Tobias. Could you tell us which Testo model you suggest for residential purposes? So do you have any preference for that?
Yeah, I think it depends what your what your needs are. So so you can differentiate between this is an analog measuring device called Testo 417, and this is very easy to use. And yeah, but the disadvantage is you don't have a storage. So if you're only interested from time to time to take measurement value, write it on your paper, then I think this is okay. This is fine for you. From the accuracy, it's the same, but with this module, you are a little bit more flexible, because if you go to the ceiling or if you go up, and then you can take the measurement, but you don't have to look on the display, because the display you can have here, or like you see on the wall in another instrument, and there you have also the possibility of creating reports and customer data and so on. And you have also the opportunity to connect other probes, other applications. But if you do only airflow measurements at outlets in the residential area, then 417 is a good device, definitely. If you need more flexibility, if you like to have Bluetooth functionality and wireless transferring the data, then I recommend Testo 440, or for experts Testo 400. with customer database. And I can also, I'm sorry, as you've seen before on one slide, we have subsidiaries in, I think, 35 countries and sales partners in nearly all countries all over the world. So if you have any question regarding measuring instruments for airflow or for all other parameters, you can click on testo.com and choose your language. Then you find the right contact person, or you write an email to my address, and I will forward it to your country, and that's also possible.
Right, thank you. Yeah, I think there are no more questions. So we are also time. So I would close the session. It was very interesting. Thank you, Tobias, for being part of that session.
Thanks for joining. Thanks.
Okay. Have a nice evening, or nice afternoon, or nice morning, wherever you are located. Thank you for joining. See you next time.
Thank you for joining. Bye-bye.
Goodbye.
Goodbye.